Hey guys, welcome back to my channel. Today I'll be talking about engineering. Okay, so I've thought about the best way of possibly doing this, and it's incredibly complicated. And to put it into perspective, there are so many engineering jobs, so many different types that you don't really realize until you're outside of university and you've gone into these massive companies and they're telling you about all the possible things that you could do. So I think the way I'm going to break it down is common types of engineering degrees that you could do at university, and then the jobs that you could do within those degrees. So once you've done that degree and you've gone out into the world, what you could possibly end up doing. So if you know the type of engineering you're interested in, but not sure what you can do with it, you can actually go into the description below and I'll put timing so you can skip to that part of the video. But if you want to learn about all the possible engineering that you could do, because say you're in year 11 and 12 and not 100% sure on what you want to do with the rest of your life, feel free to watch the entire video and I'll go through and explain as much as I possibly can. Okay, so the first degree that you normally find at universities is a civil engineering degree. And it is one of the main ones that absolutely everyone knows about. And it can get quite repetitive in the actual degree of doing specific things over and over again. But that doesn't mean that in the real world, in the big environment, that you can't do other things with it as well. So first you've got structural engineering. So structural is a subset of civil engineering, and structural looks at the physical structures, so buildings, bridges, and you do stress analysis on those particular structures. So it's pretty much how they're built and doing stress analysis. If you don't know what stress analysis is, it's a lot of, should I say physics? It's, close to physics, I think is the closest it is. Correct me if I'm wrong, but it is a lot of math and you have to enjoy doing math because you do a lot of calculations. So the next is architectural engineering, and this is also a subset of civil engineering and is actually looking at what's happening on the inside of the building rather than the outside. So structural outside, architectural inside is the best way to explain it. So it's everything on the inside of the building. So you could look at where ventilation systems will be going, how to organize specific walls for, load bearing, or where pipes are going to go. So sort of like the inside of how things are going to be laid out. So next you've got industrial engineering. So I've put industrial engineering under the civil engineering type. Most people think of it sort of closely mixed with mechanical, but industrial engineering is more of a management type of engineering role. So you're going through and making sure these industries have the right infrastructure for what they're actually doing. So you could be managing people, making sure there's the right type of engineers where it needs to be, and just looking over the way the industrial processes are being done. Geotechnical engineering. Now, geotechnical engineering is also a subset of civil engineering, but also has a whole bunch of other sort of jobs underneath it. So you could go into geotechnical engineering and do geological engineering. So you're looking at the foundations, so the rocks, how are the rocks laid out, what type of rock is there, can you drill into it, can you put a pipe down there, can you stick a pylon for a building? It's sort of looking at what is happening on the ground. Then you've got petroleum engineering. So that's physically looking at drilling sites, so finding where to drill to find petroleum and how to do that whole process. It could end up with you doing FIFO work, so fly in, fly out, where you're going out to oil rigs and being the engineer in one of those oil rigs. You then have marine engineering, and marine engineering is building things for underwater, essentially. So I don't know if it counts as boats, might count as boats. So you might do some things like helping design with boats. You can also do like platforms that sit on water. So anything to do with like the aquatic space is generally what marine engineering is. Then you've got nuclear engineering, so you can work at a nuclear power plant, do the structural integrity of what's happening at the nuclear power plant and all the geological things to do with nuclear. I don't know much about nuclear because we don't really have a lot of nuclear engineers here in Australia because we don't use it as much, but I know in a lot of other countries, such as Europe and some in the United States, it is a very popular engineering degree. Then you've got probably the most popular under the civil and the geological is mining. So you can go out to the mines and actually help them figure out where they're actually going to dig to get what they need. So you're essentially doing the entire mine site and being an engineer on the mine site. It is another FIFO job, so fly in, fly out. It is very popular here in Australia. I'm not sure how popular it is at other parts of the world, but definitely in Australia, it is one of the most popular jobs here. So next up in the degrees, you've got chemical engineering. So it is pretty much a subset of chemistry and engineering put together. So if you're a sciencey person, it's probably a really good degree for you to do because you do both. You technically work on the chemical side of engineering, so trying to find how things work together. So it could be coming up with, different plastics for strengths and that sort of thing. It's really hard to explain off the top of my head, but basically you're just doing chemistry and engineering mixed together. Now, that doesn't actually have a subset of jobs, I don't think. I haven't heard of a subset of jobs. Again, I didn't do the degree and I haven't gone into that field, so I don't know. Feel free to write it in the comments if you know of any subsets of what that degree might lead to. But it is definitely an engineering degree that is commonly found. A lot of universities do it, especially if they do science. So now you've got environmental engineering. Now, this is a degree that is probably not on the really high common scale of engineering types that universities have, but it is available at most universities. So jobs that you can do subset to that is agricultural engineering. So you're looking at how often you plant certain plants. I say plants, but I mean crops, the rotation you do them in, how long you plant them there for, what are the environmental aspects to it, what does the soil end up looking like. So it's sort of like an overall sort of, if you had a farm and you did this, what would the outcomes be? And it is a very interesting topic. And if you're into the environmental side and you want to do engineering with it and not the hardcore, hey, math and building, environmental engineering and agricultural engineering is actually a really interesting job. So now you've got material science, and I may have got material science mixed up with chemical engineering, but anyway, material science is finding different polymers, putting them together to create different materials. So it's different types of plastics, different types of metals, different types of a whole bunch of other things, but you're using environmental aspects into it as well to create a better outcome for the world. So then you've got paper engineering. Now, that might sound really weird, and it is a little bit weird. I don't know how common the job is, but you can actually do an engineering to figure out the different ways to make paper. There you go, learn something new every day. Then you also have sustainability engineering. Sustainability engineering is, I'll give you an example. You've got this big block of land and someone wants to build a retirement village on there, but they want to make sure that at least 80% of the land is still the environment. So how do you make sure that this building complex is sustainable without harming the environment? Where do you place it? What do you do with certain buildings? How would you split it up? Where in the blocks would you put it? So it's essentially making sure that what you're building and what has been engineered is sustainable in the environment that it's in. So now we come to probably the second most popular engineering degree, and this is mechanical engineering. So mechanical engineering has a lot of different things that you could do with it. And I'm going to talk about a lot that come up. I guarantee I'll be missing some as well because there's, again, as I said, there are so many engineering types. But let's try and get through as many as we possibly can. So first is propulsions. So that is working on jet engines and the mechanics behind the engines. You've got fluid mechanics or fluid mechanical engineering, which is the like hydraulic systems that go through machinery, planes, cars, that whole side of it. You've got automotive engineering, so that's looking at specifically cars essentially, and helping build the mechanical systems of cars. And then you've got manufacturing. So manufacturing engineering is essentially looking at the different types of metals and how it helps with manufacturing certain products. And a subset of the manufacturing is a metallurgic engineer. So that is someone that is looking specifically at certain metals, looking at their fatigue rates, looking at how they've been put together. So a good example of this is you may see on shows like Air Crash Investigation when they go through and they go, oh, look, there was a fatigue crack in this metal. And that is generally a metallurgist who will go through, do that scientific analysis on that metal to actually explain to you, okay, so yes, this has failed because of this reason, or this can fail at this point in time. And they are purely the experts on metal. So now we're going to electrical. Now, electrical engineering is very much different to being a sparky. So if you're not Australian, a sparky is an electrician that will come out and help you plug your lights in. Completely different. Electrical engineering is looking at a whole subset range of really intricate electronics, like within planes, within cars, within buildings, within a whole bunch of stuff. So what you can do with an electrical engineering degree is you can go into microelectronics. So that's looking at physical electronic boards that are like this big, something around that, and designing how the electronics will work on that board. It is very intricate in detail. I know a lot of universities do it as a subject to get people that do electrical engineering into that sort of mindset, because it is very popular when you've done an electrical degree. And it's very common to find jobs in microelectrics. Then you have avionics. So this is purely looking at the electronics of aircraft. So that's all of the components on the actual dashboard when you walk into a cockpit of an aircraft. So you're looking at, your artificial horizons, your lights in the panels, like how everything's set out, how those specific boxes all work, but you're particularly looking only at aircraft. So if you ever see a job with avionics, you're looking at aircraft only, but in the electrical side of aircraft. Then you also have telecommunications. So most of the time, if you've done an electrical degree, you'll do some sort of telecommunications. And that's because you're looking at RF frequencies, a whole bunch of frequencies on how to talk to different things. And generally that is covered under an electrical degree. So telecoms will be working for telecommunications companies. So in Australia, it'd be like working for Telstra or working for Optus and doing a whole bunch of different things like working on their mobile towers, and that sort of range of telecoms and your fixed wireless and your point-to-point and that side of the electrical engineering degrees. And under telecoms, you also have photonics, which is looking at the photons, so it's bringing the science into the electrical. A lot of people that do photonics generally have done an electrical degree with maybe a second degree in some sort of science, maybe physics, and generally that's how they get into those jobs. So you then have the degree that I did, which is aerospace engineering. Now, a lot of aerospace engineering degrees may be dual with something else. So for example, mine was electrical and aerospace. But if you find one that is purely aerospace, you can do a multitude of different things, which is electrical and mechanical. So you can do propulsion, so you're looking at engines. You can do avionics, again, which is looking at the avionics of the aircraft. You're doing structural, which is looking at the structural side of planes, helicopters, space vehicles. You also do telecommunications because you're looking at the telecommunications. You also do a lot of control side of things. So a control engineer works generally on the space side, so controlling spacecraft. And then there's a whole bunch of really, really niche engineering types within the aerospace field, which sometimes you hear of, sometimes you don't. But if you do get into those niche markets, you've been in the industry for about 10 years and you're an SME, so a subject matter expert on that particular thing. So then you have software engineering. Now, software engineering is very, very big. There are so many different things that you can do with it, and companies sort of mesh in a lot of different jobs classed under software engineering. So in a software engineering degree, generally you do a lot of programming, a lot of networking, and looking at that across that whole side of things. So when you come out into the real world, generally that's what you're doing. You can go into programming different programs. You can go into the networking side. You can go into the cybersecurity side, which is also very popular if you've got a software degree, and it's very common in a lot of companies to have software engineers in that security side, and the cybersecurity. They're probably the three main ones. You can also do computer engineering, which I know some degrees might call it computer engineering rather than software engineering. It's sort of on the same side, except you're going towards more of like the AI and machine learning sort of side of things. Some companies hire for that specifically, like Microsoft and Amazon, and they have those specific engineers. I think that's software sort of wrapped up. You then have mechatronics engineering. So mechatronics is looking at a whole range of different things. It's electronics, mechanics, software, all in one. So if you do a mechatronics degree, you can get a job in almost anything you really want to. It is very highly sought after because most of those people that do it have done a broad range of subjects. And a lot of companies really find that useful because they can technically put you anywhere they want. But you generally would be looking at robotics, so the robotics side of things. You can be a robotics engineer out of a mechatronics engineering degree, and look at how to make robots and make them do things, and the automation behind that. Yes. You then have medical engineering. So medical engineering is, I always thought of it as being a really hard engineering to do. That's just because it's got the whole medical aspect to it as well as engineering on top. So this is making things like, I don't know, a false heart that can beat by itself. I know that probably hasn't been made, but I'm just making something off the top of my head. Or making an arm that will help with surgery so that people don't get things wrong. So you know when hands have to be really still. So you're looking at those engineering feats within the medical field. And you don't really have subsets of different things that you could do with medical engineering. You could become an SME in something in medical engineering. So if you're purely looking at hearts, you research into doing that. So medical engineers generally do a lot of research. So if you do enjoy researching things and coming up with new ideas, medical engineering is actually really interesting. So now you've got systems engineering. Now, systems engineering, I think I've maybe seen it once or twice as like a general bachelor degree. It's mostly done as a master's, but I couldn't really fit it under anything else because it covers everything. So a systems engineer works on basically that, the entire system as a process. And within the systems engineering realm, there's a lot of things that you could possibly go into. So you've got safety engineering, so you're looking at safety of the system as a whole. So you're building the system to make sure it's safe and doesn't have any bad outcomes at the end of it. It is not work health safety, it is completely different, but safety is looking at how to make the system safer. You then have reliability engineering, so you're looking at the reliability of the actual system, so different parts, when they fail, when they need to be under for maintenance. And if you're working in sustainment on something, like you might go through and they'll be like, oh, we've changed this part when you've told us to, but it's not actually worn down enough, or I think we're changing it too often, and then you can change it based on what the maintenance people are telling you. So reliability engineering is very interesting to go into because you learn a whole bunch of things about different products all at once. You then have integration and test engineering. So this is where people work in this job and they integrate different parts of the system together to try and make them work. So if you haven't done an engineering degree, a good way to explain this is when you've got a product, so say a drone, you've got an electrical system, you've got the actual structure of it, you've got the software side of it, and you've got to put them all together to make the system actually work. So those integration and test engineers are there to integrate it all together and test to make sure all the functionality of that system works. So then you've also got the training side of it. The training can be an engineer, but also doesn't have to be an engineer. I know some engineers that have gone into the training side where they particularly write training material onto how to use the system for the customer. So if they're buying this massive system, being like, okay, so if you use it like this, this, and this, and this, it'll do what you want it to do. Now you've also got another one, which is not in a degree type. It is the program management side. So you've got the whole management side of engineering, which you don't learn in a bachelor degree unless you do some sort of systems engineering subject where you've got a massive group and one person's the project manager, which I did. But you've got a whole management side to it. So you've got the project manager who's managing the project as a whole. You've got the chief engineer who is highly experienced, normally has 20 years experience of doing engineering in some shape or form, who is signing off on all the documentation that you're putting through to say that, yes, this product will work, I'll put my house on it, it's all good. And then you've got a program manager who sits above them, who looks over the entire project and will talk to everyone. So that includes getting money from people, that includes making sure things are done right, things are done on time, making sure the project manager is doing the right thing, making sure the chief engineer is doing the right thing. The manager side of it goes up and up and up, but you don't learn a lot of that stuff while you're at uni. It's just sort of a thing that you learn in the workplace if you get to that position or you talk to those people that work in those positions. So that concludes the engineering types that I can think of at this very moment in time. I guarantee you I have missed some because it is too hard to think of all of them. Hopefully, I've given you a good explanation of the types that you want to hear about. The list is here on the side. The letter B next to the name is a bachelor degree. Letter M means that you could do it in a master's degree, and the letter S means that it's most likely a subject that you'll do within a bachelor or a master's degree. So hopefully that makes sense. If you have any questions, feel free to leave it in the comments below. Please also like and subscribe because, it means a lot to me. And see you guys next time. Bye.